students, in this part I will be covering few examples from the Chapman books, Stephen J. Chapman, Electrical Machinery Fundamentals. So here what it is saying that we have a transformer, power rating of 20 kVA, and it is 8000 to 240 volt step down transformer, 60 hertz, open circuit and short circuit tests were performed on the primary side of the transformer, and the following data were taken. So what it is saying is that there was a transformer in which they performed these tests. First, the open circuit test, where the terminals were open and all the values were taken at the primary side. So here the values were taken on the primary side, and this was open circuit test, and we got VOC, IOC, VOC measured at the primary side. And the second test, that was the short circuit test, it was also performed and all the values were taken at the primary side. So that's a difference in the previous example that we did in the part 1 of this lecture series. There was a little bit aspect of a sort of confusion for the students, but in this side we have also, by using these values, whatever the values we will calculate, that will be the values of the transformer reflected to the primary side, because all these values are taken from the primary side. So the equivalent circuit that we need to find out the values of is actually this equivalent circuit, and this is RC, that is will be reflected to the primary or the high voltage side in this example also. This will be XM, I call it P ref, and this is R equivalent P and X equivalent P. And what I mean by the reflected to the primary side is our transformer is this model is reflected as this, that the secondary is being reflected towards the primary side. So we have to calculate the values of all these elements, and I will not be solving everything, but this is very similar to what we have previously done. The values of all these components can be calculated by two methods that I have also shown in the first part of the video lecture series. So to calculate the magnetization branch, we use open circuit test, and for the open circuit test we know that what we need is theta is cos inverse POC over VOC IOC, and we then calculate the admittance, that is IOC over VOC, and the angle with the minus sign comes like this. So if we put all these values that are given, so the power factor for this will be, the angle will be 76.5 degrees, and cos of this is actually 0.234 lagging. POC, here there is a mistake, this is POC. Okay. And when we want to calculate admittance Y, it will be IOC, and this is this value, and VOC this value, and this will actually become equals to so 2.68 into 10 raised to power minus 5 with angle minus 76.5 degrees. And then when we convert this will become 6.3 into 10 raised to power minus 6, and this will be 2.6 into 10 raised to power minus 5 J. So this is actually equals to, this is actually admittance. We know y equals to 1 over z. So this is actually equals to 1 over RC minus J1 over XM. So we can compare these values, and the value for RC will then become 1 over 6.3 into raised to 10 raised to minus 6. That will be equals to 159 kilo ohms, and our value of XM will be 1 over 2.6 into 10 raised to minus 5. That will be equals to 38.4 kilo ohms. So by using the open circuit test, we were able to calculate the values of core resistance, which is corresponding to the losses in the core, and the impedance 38.4, which is showing the magnetizing effect of the core. So the next part is related to calculating R equivalent and X equivalent, and these values can be calculated by the values of the short circuit test. Again, we calculate the theta. This is cos inverse P short circuit over V short circuit into I short circuit, and we have the values. We have V short circuit, I short circuit, and P short circuit. So we can find the angle, and that will become 78.7 degrees, and for the power factor of this, by cos of this angle, we get 0.196 lagging, because we know there is no capacitive effect. All we are talking about is the inductive effect here, so the current will be lagging. Now to calculate the series impedance, the impedance of this is series impedance is actually equal to V short circuit over I short circuit, and we have the angle theta, and we have the value again of V short circuit 489, I short circuit 2.5 ampere. So the value of this will be calculated to be 195.6 angle 78.7, or we can write this is 38.4 ohms plus J 192 ohms. Now this is actually equals to R equivalent to P. This is actually equal to X equivalent referred to the P. So we will have the values here. We will have, this will be 38.4, and this value will be 192 ohms. So here we get these values, and the equivalent circuit has been created. Whenever you are asked to draw the equivalent circuit, you should also show the relationship of the voltages and the currents. That is very important. This part, it tells you where what side the transformer is being reflected to. Okay, thank you. I hope it helps.